Alright, so in this lab here, we're going to be doing a gas collection experiment to hopefully, using the ideal gas law, find the molar mass of a gas. I'm just going to read for you the temperature right now, just on a thermometer here. Currently, we're about 22.9 degrees, plus or minus 0.5. Make sure you change that to a Kelvin temperature before you use your ideal gas law. I have my mass balance turned on here. We're 0 to begin with. So I'll start off with the empty Erlenmeyer first. You can record this mass down here. It says 102.18 grams is the empty Erlenmeyer. If you like, you can actually tear it, or you can zero it here. The error would be 0.01. Your lab manual says put in a scoopful of this cupric carbonate as our compound that we're going to thermally decompose. Just going to be very careful here as I toss that in there. So there's a nice scoopful. I'm going to put it down there again. So the total mass here, I didn't tear it, so you'll still need to subtract off the mass of the empty Erlenmeyer. Currently it reads 105.76 grams, again plus or minus 0.01. Again, I'm going to set this up here. I'm going to hold it into my clamp here first, because we're going to be heating using a Bunsen burner. You don't want to be holding this Erlenmeyer here as the reaction is occurring. I'm going to seal the top of it using this lid here. Remember, just before I put the Bunsen burner back on here, remember we have a closed system here. This is going to be releasing one gas. We're hoping the gas is going to travel through this rubber hose here. The open end of the rubber hose is entering the gas collection tube. I've refilled the gas collection tube full of water, so the water mark is up to here. And the hope is, as the gas steadily gets collected, it's going to push the water out of this tube here. Because there are volume readings here on the side, I can actually figure out what the total volume of gas collected is. Right? So I'm ready to strike my Bunsen burner here. So here's our Bunsen burner. Okay. It doesn't matter, you can use an orange flame or a blue flame. I generally prefer blue flame because we develop a little bit less soot. Okay. Let's see if we can get it to a slightly bluer flame. You don't need it too tall, okay? And just be careful here as you're holding the Bunsen burner. Again, this is going to serve as sort of an on-off switch for your reaction. Because of thermal decomposition, if you're heating it, it's going to decompose. If you're not heating it, the reaction will stop. I'm going to heat it until this is roughly half, just in case there's some leftover gas going through, and then we're going to have a look at what the total volume collected is. So let's just heat it there. Try to move the Bunsen burner around. You already start seeing bubbles forming on the far side here. Because we have a sort of a continuous measure of how much volume is actually being collected, you can actually measure the rate there. Okay. We're roughly about half here, so I'm going to take off the Bunsen burner. I'm going to turn off the Bunsen burner as well. Okay. Let the leftover gas sort of suck its way through. Again, you just want to make sure you're between 0 and 50 so that we can still make a reading. I know you probably can't see it from there, but I'm just going to make a reading for you here. Bottom of the meniscus here, let the leftover gas get through here. We're looking at about 45.50 plus or minus 0.05 as the milliliters. Because as this cools down here, it creates some negative pressure. It can cause a vacuum to form, cause something called suckback to happen. So once you sort of have a steady volume reading here, I'm going to pull out the open end of the rubber hose just to make sure our volume is just sort of sealed inside. I'm going to measure the mass difference. We had the empty mass, we had the mass with the powder before the reaction. I'm just going to let it cool down a little bit because it's still going to be hot from the Bunsen burner. As we pull over our electronic balance again here, make sure it is 0 to begin with. And then again, once it's cooled down, I'm just going to plop it back on the electronic balance. We're going to record that mass down. You'll still need to subtract off the mass of the empty container, but this would be the mass left over. If you took the mass before the reaction, the mass afterwards, you do a subtraction there. The only reason why the mass has changed is because that one gas was actually released. Okay? So let me give it a feel here. Seems like it's cooled down a bit. Okay. I'm going to very carefully here take off the lid. And then I'm going to hold the Erlenmeyer, take it off the clamp, and then just going to put it on the scale. This is the final number that you need here. This one currently reads here 105.71. Okay, you might find here the mass difference here wasn't all that great, so that's going to be something to talk about in the experimental error and see how you can make improvements for next time. Thanks, guys.